Hi, I'm trying something new. We're starting with the page right up at the beginning here. This is the last part of chapter 10.3, the fourth video. I wanted to give you an example of solving an equation. You actually have the tools to solve the equation with what we've done so far, but it's a little intimidating looking to look at an x here in the denominator of an equation that has two fractions. It's a proportion. There's two different types of radicals going on. There's a root 3 radical and a root 15 radical. There's plus signs there's just a lot going on. So let's see what happens here. I would think the first thing we're going to do, let me get some color here. Otherwise it looks like we're in black and white. I would think the first thing we would do is cross multiply. So we're going to take x times 4 root 15. That's going to be 4x root 15, although you could write that in any order you want. That's this part. And then we're going to cross multiply this way. And here we have to distribute. So we have to take the 1 times the 1. I'm going to put an equal sign here. 1 times the 1. We have to take 1 times root 3. And then we're also going to take 1 times root 3. So we're doing the inner and the outer. That's going to be 2 root 3's. So plus 2 root 3, because we're going to have 1 times root 3 and 1 times root 3. So that's 1 times root 3 is root 3 and another root 3. That's 2 root 3's. And then we have to take root 3 times root 3. That's going to be plus 3. Almost did plus 9. That's not right. It would be radical 9, which is 3. So I'm going to simplify this. 4x root 15 equals 1 plus 3 is 4 plus 2 root 3. All right, now we have to get the x by itself, so we're going to divide, right? We're going to divide by 4 root 3. Divide by 4 root 3. So dpe 4 root 15. We're going to divide by 4 root 15 to get the x by itself. Divide by 4 root 15. So x equals 4 plus 2 root 3 divided by 4 root 15. Okay. Well, maybe we can cancel a little bit of this 4. You can't cancel the 3 and the 15 yet. And the 15 is as a radical in the denominator, so that's no good. This is made up of root 5 and root 3, but there's no root 3 over here. We got to get rid of this out of the denominator anyway. But we can reduce. Got to be careful reducing. Each of these 3 terms, 1, 2, and the bottom one, 1, 2, and the bottom one, all have a 2 in common. So we can reduce. We're not actually doing division property of equality. We're just reducing. We can reduce the whole fraction by 2, giving us that. Right? Divide that by 2, but divide that by 2, and divide that by 2. All right, so now we have this. Now we have to rationalize this denominator. That's going to be multiplying by root 15. We don't have to multiply by the 2. That's just going to make our numbers bigger. So now x equals, so give me a little bit of page here. X equals, let's see, 2 times root 15. And root 3 times root 15 plus, that's going to be root 45. Okay. 3 times 15, 45. 15 times just 2 is that. That's fine. All over 2 times root 15 times root 15. So that's going to be 2 times 15, which is 30. The 45, the 15 we can't do anything with, but the 45 you can. The 45 has a 9 in it because root 45 is equal to root 9 times root 3. All right. So x, let me go a little further down here. X equals, let's see, 2 root 15 plus 3 root 3, because root 9 is 3, all over 30. And if these two had something in common, the 2 and 3, we might be able to reduce this, but I'm okay leaving this just like this. And I'm not sure there's anything else we can do to it right now. I don't think so. I think that looks good. So an equation like this can have a lot going on, certainly. So it is a little intimidating to try. So good we did that example. Now with that, you're ready to do all the homework, and feel free to ask me some questions when we get to class. Let me see if I can, we'll do this. Hey, and we'll see you soon.